Let us solve the exercise number 3 in the part B of data structure lab. In this exercise, we are supposed to sort the given list using quicksort technique. Now, before we venture into the quicksort, let us recall what is this quicksort all about. Now, when you were there in your high school or maybe in primary schools, during the prayer or during the assembly, your teacher used to ask you to stand in a line, and that line generally means you have to stand in the ascending order of your height. Now, what is being done is before the assembly begins, you and your friend used to stand in any order that you prefer. And when the teacher says that you are supposed to stand in a line, that means to say that you are supposed to stand in ascending order from the shortest one to the tallest on the last. What you generally used to do is you will find a position. So you will somewhere you will find you try to find your height, and you will try to locate yourself or find a position such a way that all of them who are in front of you, they are shorter than you, and all of them who are behind you are taller than you. They may not align, or they may not stand in the ascending order, or they may not stand in the proper order, but your position you will sit you will maintain in such a way that all of them who are before you were shorter than you, and all of those your friends who were after you were taller than you. And eventually what the other students would have done is they would have also done the same thing. Your friend would have done the same thing. They would have also interchanged their position, and they would have also stood in the way in such a way that all the students or all of them who are before them are shorter than them, and all of them who are after them are taller than them. This way, you you interchange your position with respect to the other. So the same idea is being used here. So what we are generally doing is what you did was you found your pivot position. So this you generally in Quicksort we say that this is your pivot position. So what do I mean by saying you found your pivot? So pivot position is that you took a position in such a way that all of them who are before you were shorter, whether they were arranged in the or they were standing in the ascending order of their height or not. But what you have done is you found your position in such a way that your position with respect to the remaining students were proper. The other students they might not have stood in the same way, but your position was proper. So that's the same idea that we are going to use in the quicksort. Now let's try to understand this in terms of numbers. Now I have a list here. I'm going to just copy this list and keep it separate so that if I need them, I will get it back. Now you notice that all these numbers that you see over here, all of them are not arranged in proper order. So you have to find a pivot position in such a way that suppose if you put a number here, okay, all the numbers before them must be smaller than this number, and all the numbers after them must be larger than them. That means you have to find a pivot position. So this is the same idea that was being done. You found your pivot position, and the same thing is done with respect to the numbers also. How can I find my pivot position? The idea is we can randomly take any position. Either you can take the first one and then try to keep it at the pivot position, or you take the last one and try to keep it at its pivot position. Remember, the what do I mean by saying pivot position is your position is proper with respect to the remaining elements. All the elements or all the numbers or all the students with their height, they are shorter than you, and all of them after you are taller than you. So your position is proper. So this is called as a pivot position. They may not be arranged in the ascending order. So that is a different thing. But with respect to you, they are taller. This side is taller and the other side is shorter. Same thing. If I find a element over here and if I say this is the pivot position for that element, all the elements before this are smaller than this element and all of the elements on the other side must be larger than this element. So how can we do that thing? Now generally you take the first element or the last element and then try to find its position, its pivot position in the list. Okay. Some people also find the middlemost element and then try to find the its pivot position. So it is up to you. So I assume that most of the algorithm they just take either the first or the last one as the pivot position. So I try to find the pivot position for the element 5. That means to say that if I place 5 somewhere in the list, all the elements before 5 must be all the element before 5 must be shorter than 5 and all the elements after 5 must be larger than 5. So 5 is there at its proper position. How can I do that? So I take this partition. So the partition that is starting from the first element to the last element. Now you know very well, generally we take the I to indicate the indices of the array and J to indicate the indices of the array. So the I refers to the first indices, that is the beginning of this array, and J refers to the end of the or the last indices of the array. So we try to find an element which is larger than this element. Remember, we have to find a position of for 5 such a way that all the elements after 5 must be larger than 5 and all the elements before 5 must be shorter than 5. So you try to find a larger element or an element that is larger than 5 on the left hand side. Similarly, you find an element on the right hand side which is smaller than 5 and interchange their location. So this is the general idea. Suppose if you say this is the pivot position, you find an element which is larger than the pivot element on the left hand side and find an element which is shorter than the pivot element on the right hand side and interchange their position, and you keep on doing it until you find the perfect position for the pivot element. So how do I do that thing? So let's start with the simple idea. So I start from this first element. So 5, I want to place this 5 somewhere in the pivot location. So what I'm going to do is I'm going to just take this 5 and I increase this I, which is generally pointing to the first element of the array. I increase I by 1, that is I plus plus. So I will be pointing to the next element. Now I compare this with this element. Remember, I wanted to place this pivot element at the proper location. So I compare this 5 with the element 9. You find that 9 is larger than 5. So if I place this 5 here, this 9 must come on the other side. Okay. Similarly, I start from the right hand side and I check whether there is an element which is shorter than or which is smaller than 5. So in the this side I find an element which is larger. On the other side I find an element which is smaller. If I find that element, I interchange their location. So I change this, I keep the one at a temporary location. I move this to this location, that 9 to this location, and bring this 1 to the this location. So now you notice that one element is with respect to 5, with respect to this pivot, this 1 is at the proper location and 9 is there at the proper location. Now again we start with the same story. I try to find an element which is larger than 5. So I check whether 1 is definitely smaller than 5. I go next, I find 4 is smaller than 5, and then I again take this element. Where is this thing gone? Okay, I take this pointer and I move it here, and I find that 10 is there at 10 is an element which is larger than the 5. Now I have to find an element which on the, so this I stop here, so I got one element. Okay, now from the right hand side I start coming to decreasing, that is see, from 5 I'm going to index 4, 3, 2. That means j is getting decreased from the top. From the top side we are coming down. Okay, I is moving in the front direction, whereas j is coming in the reverse direction. So I take this j here, okay, and then I start moving it back. So when I move back, okay, what I find that there is one element 2 which is smaller than 5, and for the I find an element which is greater than 5. Now I interchange their location. So I temporarily copy this 2 to some location. I move this 10 to this location, and then I move it at this location. Remember, I said we are taking j is from the top side, we are coming back. From the I is from the smaller to the higher. So that means I value must be smaller than j value, so that our list is proper. So just look at here. I was in the beginning, so I was smaller and j is larger. Okay, so now we are in a position where I is smaller. What is the value of I? Remember, it is not 2. I value is 3 here. So index value. Okay, j value is 4, the index value. Okay, so this is the actual value. That is the data. This is the array index value. Now let's start looking at the scenario again. So what I do is I again start. Now I have to find the pivot position. So I again try to find an element which is larger than 5, so that I can move it to the other direction. So I start from here. I move the I to the next location. What I notice is this 10 is greater than 5. So I got one element which is larger than 5. Then I come to this j and I decrease the j by one step, and I find that okay, there is a 2 which is smaller than 5. So now you may again, if you are following the previous idea, we will try to interchange. This is called as swapping, swap the location, but this time we will not swap the location. What is the reason? See, I said that I was smaller here and j was the larger. So I value must be smaller than j. But what you find now is j is 3, index value is 3, and I index value is 4. This is violating. When this thing happens, when j becomes less than I, that means we have crossed the position. So we have crossed that pivot location. So the pivot location has been crossed. So we need to now find the pivot location, and you notice that the j is actually now pointing to that pivot location. So now what we are going to do is we are going to bring this 5 here, and we are going to move this 2 to the other direction. So let's do that. I'm going to copy this 2 in a temporary location, and I'm going to bring this 5 to the other location, and 2 to this location. Now what you notice here, so look at this thing now. Look at this 5 now. All the elements before 5 are now smaller than 5. All the elements after 5 are larger than 5. They need not be in the proper order. They need not be in the proper order. But 5 is there at its pivot location. So this same idea that I was telling you, you are there at the proper location. So your location is proper. others may not stand in their proper order, but you are there at the proper location. So in the same way, 5 is there at its pivot location. Now what you have to do is you have to ask these people who are here to arrange themselves so that they will also uh, come in the ascending order. So what, in other words, what you are supposed to do is in this list, you have to find a pivot element. So again, assume that 2 is the pivot element and the element to be placed in the pivot location. And you are supposed to find a location in such a way that all the elements before 2 are smaller than 2 and all the elements after 2 are larger than 2. In the same way, you have to do it here also. So in other words, you take this partition I to j as one subset and then try to solve it. Similarly, you take I and j for this set also and then try to solve it. So in other words, you divide it and again try to find the pivot for this smallest set. In the same way, you divide it and then try to find the pivot for this set. So you keep on dividing it. So this is called as divide and conquer technique, and until you find the solution. So let's start with the first idea. So I'm going to bring this, that is the reason I brought it here. I'm going to bring back the original list, and this was the scenario. So what did we do is we took not this one, we took I as the starting, beginning, and j as the ending, and we took this value, that is the beginning value itself, as the pivot element. So we want to place 5 at the proper location. So let's write that in the solution. So I'm going to click on this. What is this one? New file. Let's start creating a new file. Let's do that thing, and I'm going to go here. Then let's go to the next, and I will say Q sort. You can give any name for your program. As usual, I'm going to import stdio.h for my program. Done. So let's write the function void quicksort. So we will write the function first, quicksort. I'm going to take this array. Let me take the array as a, and I will take the beginning and the ending location of this array. So beginning and end location of this particular array. So this is what I am doing it. So given an array, you take the beginning location and you give the ending location. So beginning will be marked as I and end will be also marked as I, and your pivot will also point to the beginning location. So let's do that thing now. So what we are going to do is I'm going to take a variable, that is, first of all, I want this pivot, and I want I want j, and I need a temporary location for swapping the elements. So whenever I wanted to swap, I used to bring it to the temporary location and make the swapping. So that is why I have taken one of the element here, that is one of the variable here as a pivot. Now what is the condition? The condition that we are going to do is, remember, whenever we are trying to partition the array into smaller and smaller sub list, we have to see to it that the beginning is shorter than the end. Sometime what will happen is both the beginning and, suppose if there is only one element is there, then both this is the beginning and this will be the end. So when you have the larger set here, you divide it into smaller set. Again, you divide it into smaller set, and finally what you'll end up is there will be only one element. So beginning is the same element, and ending is also same element. When the beginning and ending are same, that means there is nothing to be done with it. So there is only one element. One element is already sorted. So if you want to stand in the ascending order, you have to have somebody with whom you will compare yourself. If you are the only one person on earth, then there is no ascending or descending, because you cannot compare your height with anybody else. Okay, so there must be at least two elements or two numbers with whom you can compare each other. So if the beginning and ending is same, that means there is only one element. There is no need to do the quick sort or anything. It is already sorted. So the first thing I am going to do over here is, if the beginning is less than end, then only our full logic will work. Otherwise, there is no point in writing this quick sort. Okay. Now let's go to the next part. So what is the first thing that we have done over here? So let's look at here. So both the I is pointing to the beginning location, pivot is also pointing to the beginning location, and J is pointing to the end location. So that means to say that I want to place this 5 at its proper pivot location. So let's go ahead and let's do that thing. So I'm going to say I is equal to the beginning. Okay, and our pivot is there also at the beginning. Okay, and J is at the end. So this is the condition. So look at what is the thing one. So I is there at pointing to the first location. Remember, pivot is also pointing to the first location. J is pointing to the end location. So that is 5. So this is being done. Let's look at the next thing. So what is that we are doing? So as long as J is greater than I, we have to keep on moving this I in the forward direction and J in the reverse direction. As long as I is greater than J, you can do the swapping or you can do anything. When the I and J are crossing, that means J becomes smaller than I, then there is no point in doing anything. Otherwise, J will come this side and I will go to the other boundary and you will not be able to get anything. So because J is pointing to the last index and I is pointing to the first index, this I must be greater than J. So when you increase the I value and when you start decreasing the J value, you must see to it that I and J values, whatever it is, I is smaller than J. If it is not the case, we will not do anything. So let us do that thing. So while I is smaller than J, we are going to repeatedly increase the value of I and decrease the value of J. So first what we are doing is we will try to find an element which is larger than this pivot element. So that's the first thing. So we will keep on incrementing I until we find one element which is larger than this pivot element. So how can I do that? How can I write that? So I'm going to write one more while loop over here. While, okay, a of I, what is this a of I, where I is pointing? So while a of I, okay, is greater is smaller than this, you have to keep on. So if I suppose let's say, let me just this was not the order, but just so you start comparing the value of a of I. What is I is 0 now. A of I is 5. What is the pivot element is 5. They are equal. So if they are equal, increase the I. Again compare. 5 is less than this. 4 is less than. This is my pivot element. 4 is less than 5. So you increase it. Okay. Now what you find is 9 is greater than 5. You stop at this position. So you keep on increasing I from here to here, 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 and so on until you find an element which is greater than this pivot element. Okay, so how can I write that thing? So this is a of I, so this is I equal to 0. This is a of I is 5. When I is 1, a of I will be 4. When I is 2, so when I is 2, so I'm talking about this index. So this index, when I is 2, a of I will be 9. Okay, so this index I'm talking about. So when a of I, let's go over here. When a of I is less than or equal to a of pivot. So what is the pivot value? So pivot value, pivot is pointing to the same location, 0. So a of 0 is 5. So this is same. So as long as this is the case, you increase, let me put it proper. So you increase the value of I. You keep on increasing the value of I. So find I. So this while loop will keep on iterating again and again and again and again until you will find an element, a of I such a way that this element 9 will be greater than 5. So you keep on, where is this thing on? You keep on iterating through this while loop continuously until you find a of I which is greater than, until this condition is violated. What is this condition? You find an element which is greater than the pivot element. For example, you find an element 9 which is greater than pivot element. So when you come, you just stop it here, because the 5 now has to be, this 9 has to be moved to the other location. In the same way, you keep on decreasing the value of j such a way that you find an element, let's say this is 45, let's say, just for the brevity, you find an element which is smaller than this element. Okay, so how can I write that thing? So I'm going to write this way, while okay, a of j, okay, is greater than or equal to a of 5. So as long as you find, for example, you notice over here, this is 45. 45 is greater than this one. In that case, what you have to do, decrease this j. So decrease this j. So if a of j is this one, a of j value, a of j is 45. If it is greater than this pivot element, decrease the value of j. Now there is one major problem with this one. What is the major problem with this one is, if you keep on doing like this, what will happen is, if you keep on doing like this, is I will keep on I plus plus, I plus plus, I plus plus, and it will go outside this array altogether. So there is always a chance that when you make this I plus plus here, see, when you make I plus plus, I will start from here, okay, and I will go and it may finally go outside the array. So you must see to it that I somehow reaches to the end of this thing. Okay, so I comes up to this end, not beyond that. When if I goes beyond this 5 element, because there are only 5 element, if I value becomes, see, I value is initially, I value is 0, I value is 0. So this is I value. Then I becomes 1, 2, 3, 4, 5. If I becomes a 6, then you just stop it. So I am going to put that condition. And there is one other condition. What is the one other condition? I must be smaller than the end element. Yeah. Otherwise, I will do this. I will go beyond this scope. Similarly, if you keep on decreasing j is initially j value is 5 here. then j becomes 4, 3, 2, 1. If you don't put a break here, j will go to -1, -2, and so on. So you have to put one condition here. And what is that condition? The condition is you must see to it that j is greater than the beginning. Otherwise, it will simply go beyond the limit. Okay, so such a thing should be stopped. Now remember, suppose let's come back to the, I think I have made a lot of changes from my original list. Anyhow, should have maintained the original list. I think original list, this was the original list. So, okay. Now what you found was, you found one element here and other element, let's say here. Okay. And you notice that I value is smaller than j value. If that is the case, you swap them. Okay. If I value is smaller than j value, you swap. Swapping means you interchange their location. Bring this 9 to this location, bring this 1 to this location. So let me write that story over here. So I'm going to say if I value is less than j, then I will write this swap. How did I do it? I first brought one of the element. You can bring any one of them. So first bring one of the element to the temporary location. Then bring this one to this position and this one to this position. So this is what I'm going to do. So first to get anyone, you can get it. So get a of I, let's say, to the temporary location. Then you say a of I is equal to a of j. You can do it any, this is swapping. You've done it in your first year. So this step is called as swapping. You interchange their location. So first bring one of the element to the other one, overwrite the other element, and from this you bring it to the previous one. So this is swapping. So you are going to do this continuously, okay, until this while loop breaks, until this story. So you are going to make the swapping and swapping and swapping until something like this will happen, where I will not be equal to j. So this was the original condition. When you have this situation, so let's say, let me do, this is the thing, this was the story that we had here. Okay. When you had this like this, okay. So this was the situation. Just recall what I did in the previous part of this video. So where I and j are pointing to the same location, that means I is not less than j, I is equal to j. In that case, j will be pointing to a location. So j is like this, j was like this. So j is smaller than the I value. When this happens, you get this pivot element to here and move this element to the pivot location. So after this while loop, when the while loop ends, so you will find a location, or you will get your pivot location. So in that location, bring the first element and then swap the other element there. So this is what I'm going to write. So after this while loop, so when this while loop ends, I'm going to do this one. So temporary location, I'm going to move the pivot element. You can move any of the element. And then I'm going to say a of pivot is equal to whatever the element which is there. Remember, j is my pivot location. And I'm going to say a of j is equal to, again, I'm swapping them. So this is this story. I hope you are familiar with this story of swapping. So this bringing it one element here and bringing it to the other. This is called as swapping. You interchange their location. Okay. Once this is done, so let me just bring it here. Okay. Bring it here. Now, once this is done, what did I said is so 5 is there at its proper location. 5 is there at its pivot location. Now take this part, that is the subset or the first part of the array or first partition of the array, and try to do the same operation again with this part. Similarly, take the other side and then try to find the pivot location. So in other words, once you are there at your position, the other student will also try to find. So these three guys will also try to interchange their location in such a way that this person will make his location proper. Okay, so he or she will come at the proper location such a way that all of them all before them are in the sorted order, and all of them are or shorter, and all of them are longer. Again, you may have many students. I have just given a simple example over here, who are going to arrange themselves. So in other words, once you get this 5 at its pivot location, okay, then take this subset and then perform. So in this subset, I will be this, j will be here. So what is the value of j? Current value of j is 3. You notice this is the index value. So I will start from this. For this array, for this subset, I will be 0. Again, j will be not 3 because 3 is already there, its private location. J will point to this location, that is 2. So how can j get to 2? J is less than the previous value. So previous value of j was 3. So 1 less than that. Again, you do the same thing. So let me write that story. So I'm going to call recursively, I'm going to call this quicksort again. So my function name, look at this, my function qsort. I'm going to call this same function qsort again. And I'm going to pass the array, the same array. And I will start from the beginning till j minus 1. So for this side, j is same as the beginning, and then I is same as the beginning. J is 1 less than, new j is 1 less than the previous j value. What about for the other one? I'm going to just remove this one. What about for the other one? For the other one, I value will be 1 greater than the j value. So look at here. So this I will start 1 greater, this is 3, 1 greater than 3 is going to be 4, and the end value will be definitely end itself. So for the other set, for this set, you are going to say that q sort, again same thing, q sort, array is A, the starting is j plus 1, okay, end value will be end itself. Okay, so this one is I will start from j plus 1. For this previous one, I will start at the beginning. What about the j value? J is end itself. For this, I value will be here, j will be here for this array. Okay, or for the right hand side partition. This will continue until all of them will arrange. So this is how you wish to arrange in your high school or maybe in the primary, and this is how the algorithm will work. That's such a simple algorithm is that. So let's write the main function for that. So our entire program is over. When I say entire program, my entire logic is over. So let me write the main now. So I'm going to write the main. So we are going to just test them. So I assume that you will not type more than 25 elements during the array, and even though I have taken the array of 25, you will not go up to 25. You will just fill the array with the n number of elements. Even though the array is very large, you will restrict them to n number of elements. So you will fill only n number of elements. N is generally 5 or 6 during the examination. And for whenever we talk about array, we use the for loop, and for the for loop I need a counter variable, and generally that counter variable will be I. This is in the main program. So you know how to read an element into the array. How to read the element into the array? You are going to use a printf statement, and you are going to say printf enter total number of elements. So this is a general story of the reading anything into the array. Remember, if you don't know anything for during the examination, do this part. This part you know very well. For any array related thing, you will read the value of n, and then you will read the value of n elements into the array. So let me use the printf statement, and I'm going to say enter n elements into array. Okay, so this is n is whatever n that you have read. For example, if you are reading, if this scanf you are reading 5 here, so this is going to be enter 5 elements into the array, and for that we are going to use a for loop for I is equal to 0, I less than n, I plus plus. So this is the general story that you are going to do it, and you are going to use a scanf for that, and in this scanf you use percentage %d. I think that e is down now. Okay, and ampersand a of I. So you read that one, and after that you call the quick sorter. So first you call this function quick sort, you supply the beginning and end. So let's do that thing. So I'm going to say q sorter. My array is a, beginning is 0 and ending is n minus 1. Remember, this is an array. I hope I don't have to explain that story. So in the array, the first index is 0 and the last index is 1 less than the value of n. So if n is 10, index will start from 0 up to 9. So that is why I will reduce the 1 there. Okay, done. Quick sort will be performed. After that, I'm going to say printf sorted elements are okay. This advertisement, they are not paying me, but they are getting the free advertisement. I can't help it. I will uninstall that software now. Okay, so sorted elements are, let's see, and let's use the for loop, and we are going to print the elements. That is not taking it up. A of I, we will print it, but a very important thing, you just put one space here. So you see to it that you put some space here, otherwise numbers will touch one another. Okay, so that is being done. Hopefully not done any mistake. So let's see. Let me save it, and let me save everything, and let's compile and run. If there is an error, if your program is not working like this, what are you going to do? So suppose if you get like this, what you will do? You will go to the view and you will ask for the logs here, or you press F2 and it is going to say that there is this syntax error. What is this syntax error? This is a while loop. Okay, so done. Let's save it and let's run it, and you get, let me say there are totally 5 elements are there. So I'm going to say 10, 20, minus 5, 9 and 0. Okay, so you notice this minus 5 first, then 0, 9, 10, 20. So this is in the ascending order. So that is what you are supposed to do. Thank you for your interest. We will meet again in the other exercise.